Okay, in this next video, we're going to configure ISCSI for the AD server. What that will do, it will provide storage to nodes inside a cluster, which can then be used for the likes of failover clustering with SQL. So the first thing I need to do is look at the ISCSI target services. We can see that's currently not installed at the moment, so we need to install the ISCSI target services within here itself. So we're just going to keep it fairly standard. It's going to use the ISCSI target server in relation to that. There are other providers which we can use, but to be honest with you, a standard target server is adequate enough for our needs. So we'll click next, and then next again, and then we'll install the target server onto the Active Directory server itself. So we're going to wait for this to complete, which it now has. We can close this. The next thing I need to do is add some storage onto the AD server, which will be used for the ISCSI target itself. So what we're going to do is drag some storage onto the AD server. Depending on your needs, obviously apply that accordingly. Primarily there's going to be two volumes to create. One's going to be the quorum, and the other one is going to be the data disk using or requirement for the SQL database itself. This example, I'll just make this 100 gig for the moment. I'm just going to call this the ISCSI storage. And there's no image on this as it's a blank disk that we're going to be using. So I'll provision those changes and provision now. This should be relatively quick as we're just adding a blank disk to a server. There we go, and that's now complete. So if we switch back to the AD server itself, the target services are now installed. The next step is to create a virtual disk, but before I do that though, I need to look at the storage layout on the server. There's a number of ways we can do that. We can do this via disk management. And in here, what we can see is a number of disks which are there. This one currently is offline, which is the new added disk. So if I add this disk and then online this disk, we should be able to start creating a volume and a file system and then utilize that. Yep. So what we'll do is we'll just initialize this disk. I'll keep it as MBR for the time being. I'm going to create a new simple volume on there for the relevant ISCSI targets that we're going to use. I'm going to use all of the available size of the disk itself, and again allocate a drive letter as well as formatting as well. And again, I can change the volume name if required, so this could be ISCSI. And then finish, and then we should see a D drive available in the Explorer view. So if I look at here, we've got the D drive there. Okay, so the next step in the ISCSI target is to create the volume and also apply the relevant initiators which are going to connect to the target server so they have access to the system itself. So I would normally start provisioning the SQL servers, get those up and running, and then I would normally enable the ISCSI initiator software in its deployment as well. So we can go through what that process sort of looks like as well. So what we're going to do next is add the two SQL servers to the virtual data center. So it's a matter of creating a couple of servers. So this is going to be the SQL node 1. Oops. And we'll assign 2 CPUs and 4 gigs of RAM for the first server. And then we'll also create the second server for that as well. So here SQL hyphen node 2, and again 2 CPUs and 4 gigs of RAM for this server. Regarding the actual disk for the SQL nodes themselves, there's going to be an image which is required. This is used really for billing purposes as such, really. So when you apply for using the IONOS SQL images, what you'll get via support in the image manager, you should see an image which will be the relevant SQL version that you're looking to deploy, along with the Windows operating system as well. So for this demo, what I'm going to do is install SQL Standard 2017, and it's going to be sitting on a server 2019 image itself. So we'll see that as we deploy the disk. Note the operating system needs to be the same, obviously, for the second node. They need to be built pretty much identically in relation to the operating system, service pack levels, etc., for cluster validation, those sort of things as well. So we'll drag the disk in for the node, and we'll select the size. So the size we're going to go for is 100 gig. And we'll look for the own images which are going to be uploaded for you via support, and then choose the appropriate image requirements there. This example, I'm just going to install the SQL Standard 2017 image, which is running on Windows 2019. So this would be SQL 1 boot and 100 gig, so we're happy with that. And what we could do is look at availability zones as well. So we've got 2 nodes here which are going to be ideally in different zones. So what we'll do is we'll place the actual node itself in zone 1, and if we highlight the SQL node 2 here, what we'll also do is place that in zone 2. So we're actually specifying the relevant zones for resiliency purposes. We'll add the second disk, this time to SQL Node 2. So what we'll do is we'll drag a disk over there. This is going to be for SQL 2 boot. Naming doesn't matter. You can obviously use whatever naming conventions you want there. And it's going to be 100 gig in size. This time we're going to specify the image. We're going to use a Windows 2019 image for this build, as that's the same operating system which is on SQL Node 1. We'll give a password for the administrator account, which will be used when we log in to the system. Notice on SQL 1 there wasn't a password set for that. There is a document which I'll bring up in a minute, which will go through what the default password is for the IONOS images, so you'll have that. Similar to what we did with the disk, we can also allocate different availability zones for the disk in relation to this. So again, we can choose, the first one's on zone 1, we'll do zone 2 for the storage in relation to SQL Node 2. The other thing we need to do is look at the networking. So what we'll do is we'll drag the network over to the LAN and do the same for the second node. And then we can look at configuring the network IP address. So we set it as 10.10.1.21. We don't need the DHCP for this network configuration at the moment. And then we'll do the same for the second node. So 10.10.1.22. And again, we'll just disable that DHCP flag because we're going to use static IPs inside of this deployment itself. Okay, so we've got our 2 servers which are pretty much ready to go. We'll now deploy and provision these virtual machines, and then once that's done, we'll then start looking at configuring the networking, and then we'll look at enabling or creating the ISCSI initiators for the shared storage as well. So with that, let's provision the changes. And then we'll provision now. The other thing I want to note as well, just while this is going on, is the pre-provisioned or pre-imaged disk for the IONOS SQL images. Ideally, if you start something like 2 cores and 4 gigs of RAM, then that will deploy perfectly on our platform. What you can then do is once it's actually deployed is then increase the number of CPU and RAM, to your requirements that you have for your database. The image itself is set in a way that if you do allocate something like 8 CPUs and 32 gigs of RAM, the actual image itself won't provision properly, and it will actually break the Windows deployment just through the nature of the way in which the image has been provided. So if you start with something like 2 CPUs and 4 gigs of RAM, then the actual image itself will provision, and then we can log into the environment itself. So we'll just leave this going. While that's happening, I'll just bring up the SQL documentation as well that we can use. So we can see that the provision is now complete. So let's look at the relevant servers. So we'll start by creating the network configuration inside the virtual machine itself. So we'll start with SQL Node 2. So if I console to this server, then what I can do is if I log in and obviously use the password which I set for the administrator user when I provisioned this VM. Again, just make this large so I can see the whole screen. And then if we look at the network configuration, and just open that, we'll just modify the network config to the correct settings. This console browser is a bit slow. It's not the fastest responsive UI. So ideally, once the network is setting up, I can just RDP directly to this server from the Active Directory server itself. Okay, so the gateway is going to be back onto the LAN adapter IP address of the OpenSense appliance. The DNS server I'll be using is going to be initially the AD server for the primary, and then I'll just use Google for the additional alternative DNS setting for the moment. And then if I click OK on that, okay, that's fine. Close my windows down. And then the other thing I'm just going to do on the Windows server is I'm just going to make my life a little bit easier. I'm just going to switch off IE security for the moment. Again, I could do this remotely, but the other thing I do want to do is just switch off the firewalls for the moment as well. Just make my life a bit easier. So let's change that. Okay, so that's all the firewalls off. The other thing I'm going to do as well is just rename this server for the moment, so I can just go through and reboot, and then I can reconnect when I need to. So here, if we just change the name of the server. And again, I could probably just do this with the RDP session as well. So we can change this to SQL Node 2, sorry. And then OK that. And then close, and then restart this node. I should be able to get into this server once it's restarted via RDP. Okay, so on the first node then, this is the one with the IONOS provided SQL Server image itself. So once you log on to the server, there is a set password which is defined via a document which you typically would get via support when you apply for using the IONOS SQL images. In this document, a little further down, it talks about how you create the virtual machine, which is what we've sort of done. And then towards the end of this document, it talks about logging into SQL Server for the first time. So there is a default password which has been set, which we can then use for logging into the system. So what I'm going to do is just move this down a minute. Then I'm going to also increase the size just so I can reference that when I go through the install or the logging in of the system itself. Okay, so here we are. This is node 1, SQL node 1, as you can see. What we'll do is we'll send the, sorry, wrong link, send the key combo of Control-Delete to log in. So we'll send the key combo to log in to the server. And it will tell me that well, I need to log in obviously with the relevant password. So here, BGMT2GRS7X, XV5. Okay, and then we must obviously change it to a password of your choosing. Okay, so we'll just accept that, and then we should log in. Okay, password's changed. And again, I'll just maximize the screen for the moment so I can see the bottom of the taskbar. Okay, just wait for the network icon to appear. There we go. Let's get rid of that. And then open the network settings. Change the adapter, and again, just specify the relevant IP that you want to use for this first SQL server. Okay, in my case, it was 10.10.1.21. Okay, and okay again, and okay again. Okay, so we'll close that. We'll look at the relevant server manager as well. Again, we'll change the Windows name that we want to use. So this can be SQL -node 1. We'll add it to the domain once we've configured the ISCSI configuration, etc. Okay, so we won't restart yet because I want to change the IE settings again in relation to this build, and then I'm also going to switch off the firewall again as well. So we just turn it off and switch off private, and we'll also switch off public as well. Okay, so that's set, and then what we can do now is restart this machine. So let's do restart. Okay, all right, I'll minimize that machine for the moment. We don't need the rest of this documentation. It just talks about really how to utilize the management studio, connecting to the database, etc. as well, which I'm not really going to go into for this demo as such. So we've got our two nodes up and running. We need to now configure the ISCSI initiator on those, and then we can create the relevant volumes for the SQL database, which is going to be used for for level clustering in this example. So if we look at the RDP session back again, what we can do is create a remote desktop. We'll go to number 22, which should be up and running. Great. Got our credentials. We've got a good connection there. And then what we should see, and again, I'll just pin this to a taskbar to make my life a bit easier in the future. If I look at the current disk configuration, what we should see is a single disk obviously on there at the moment, which is going to be the C drive, which we can see. What we need to do is get the ISCSI initiator up and running, connected to the relevant target, and then we should be able to create disks, which eventually will be seen in both the SQL servers themselves. So what we can do is go to the ISCSI initiator by looking for ISCSI. The feature is currently not running, so we'll enable the service. And then we need to put the target. The target is the AD server, so we can here put 10.10.1.10 and then click on Quick Connect. We can see the target, click Done. And now if we look at the other SQL server, so again just move this around a bit so we can get access. This time go to 10.10.1.21. The password reset also should work as well. And we're logging in. And again, just look at the ISCSI initiator and put in the relevant values in there. So here if we look for ISCSI, again, enable the service. Add the target and click Quick Connect and get connected and done. If this connected screen doesn't come up, don't worry too much about it. You typically would need to reconnect or reestablish the connection possibly as well. So wouldn't worry too much if it's not there. It may be empty. Just click on Done for the moment. And then we can look at that as we get connected. Okay, so we okay that. So the initiator's running now on both the systems. So it's a matter of me now to create the relevant virtual disks for this. So what we can do is create the virtual disk. We've got the disk location. It's going to be the D drive. We're going to go next. Let's just move this up a little bit. The name for the virtual disk is going to be the quorum disk initially. Notice the path which is going to be saving that virtual disk. The size doesn't need to be huge. It can be anything from like 5-10 gig in size really. So I'll do a 5 gig quorum. I think that's going to be more than adequate for our needs. You can have a fixed size, so it will lay out a full 5 gig file for the disk itself, or you can have dynamically expanding. I'll set dynamically expanding for the moment. There's already a target installed, I guess, on this at the moment, which is why we saw the connected system. What you typically could do is click on New Target and go through the process of giving the target a name and then selecting the relevant configuration for that or initiators for that as well. But that's fairly straightforward. So if we click Next, you'll have information about the relevant disk that's been created, and then click on Create and then close. And then we just repeat that for the data disk. So we do a new virtual disk on D. Again, just move this up a bit. This is going to be the SQL data. This will be an 80 gig in this example. It be whatever size obviously you want to use for your data. We're going to attach it to an existing target as opposed to creating a new target for each device. And again, just gives us a summary. Click on create, and then we should see the relevant disks which have been created there itself. So we click on close, and now what we can do is just make sure we can actually see those disks from the relevant servers. So if we look at the first server and go to the ISCSI initiator, we can see it's currently connected. If that wasn't there and it was blank, then what you can do is click on connect, and then you would click on add the relevant add relevant target in there, and then you'll have a connection status. What we can do here is click to volumes and then click on auto configure. And then what that should do is find the two devices which have been created. So you'll have your quorum as well as your data disk in there. If we click on OK, it's the first server done. And then if we look at the second server, did I already open that? Let's have a look. Yeah, second server is already open. And again, it's currently connected, which is fine. We can go to volumes and devices, auto configure, and again, we've got the two disks in there. If we click on OK, what we will see in the device management is those two disks that have come in. What we do now is basically online each of those disks. And then what we can do is initialize the disks themselves. So the two disks, we're going to use MBR for the master boot record against those disks. We're going to create a new simple volume, which is going to be the 5 gig in size. We can change the drive letter if needs be. I'll use key for quorum for this. And again, we can add new volume for the SQL data. So again, the size, I don't know, I was going to go S, I guess. And here, SQL data, next, and finish. So we've now got our two disks that we need to use for the clustering, as well as the SQL data itself. So that's that. If I switch back to the other node, just so we can see what it looks like on that environment as well. So if you right click the start button and then go to disk management, what we should see again are the two disks. I may need to do a refresh on this, so I can just rescan the disks. And then what we can see are the two disks which are currently offline because they're online on the other server at the moment, which is the default expected behavior, I guess, really in relation to ISCSI and connectivity. The last thing you want is both servers accessing the same storage because you'll have corruption. So it's just really through the nature of which ISCSI works. The other server is grabbing those disks and locking access to it at the moment. So with that, that's really the iSCSI element configured and working. Yeah, and now the next step is to add those SQL servers to the cluster and then go through the process of the SQL clustering itself.